Alright, a particle moves along the x-axis so that its velocity at time t is greater than or equal to 0 and less than or equal to 5. It's given by v of t equals 3t minus 1 times t minus 3 at time equals 2. The position of the particle is x of 2 equals 0. So question A is asking us to find the acceleration of the particle. We start with the velocity, which is v of t equals 3t minus 1 times t minus 3, which if you multiply out equals 3t squared minus 12t plus 9. To find the acceleration, you have to take the derivative of v of t, which is 3 times 2t minus 4, and we have that a of t is increasing. So B wants you to find the total distance traveled by the particle. You start out with x of t, which equals the integral of v dt, which equals the integral of 3 times t squared minus 4t plus 3 times dt, of course. So if you take the integral of 3 times t squared minus 4t plus 3 times d of t, you get t cubed minus 6t squared plus 9t plus c. Now you have to find c. Since you know what x of 2 equals 0, you'll plug into anywhere there is a t. You end up with 2 plus c, meaning c equals negative 2, giving you the equation x of t equals t cubed minus 6t squared plus 9t minus 2. The points you want to use to find the total distance are the endpoints, and where the graph crosses the x-axis, meaning your points are 0, 1, 3, and 5. Plug these points into the equation and you get the chart that shows the total distance being 26 units. Now we have been tasked to find the average velocity of the particle over the interval of 0 to 5. So to find the average velocity, you need to use the equation of the integral from a to b of 1 over b minus a. So if you plug in your values, you get this. Do some solving and you get the average velocity of 0 to 5 is 4.
And here we have a problem asking us to find on what intervals f is increasing. So hither you have some sort of an equation where we find a chart indicating that on the interval of 3x minus 1, you find that we're decreasing and then increasing and then increasing again. This is the f prime of x chart, of course. And on the following interval, you find that x minus 3, you're decreasing, decreasing, and increasing. Ultimately, we find that the graph is increasing and then decreasing and then increasing. So our answer becomes f is increasing when x is less than or equal to 1/3 or x is greater than or equal to 3. This time we find that the graph of f is concave downward when f double prime of x is less than 0. So f double prime of x is equal to 6x minus 10. So we find that f double prime of x is negative towards the leftward side of 5/3 and more positive on the rightward side of 5/3. So we find f is concave down when x is less than 5/3. This time we find that f has a relative minimum when x is equivalent to 3. So it's also directing us to see problem A for some reason or rhyme. We come down to find that f of 3 equals 27 minus 45 plus 9 plus some sort of bizarre Celtic symbol, and that equals 11. That translates into that same Celtic symbol equaling 20. So our answer is f has a relative minimum of 11 when the Celtic symbol is equivalent to the 20.
Alright, so here we have f prime of x, who is one of the lesser known transformers. And by looking here at this graph, we can see that his stock portfolio has recently taken a dive, but he's optimistic about his most recent turn. Looks fairly promising. That's pretty much how calculus works.
I don't think that's how it works.
Wait, what do you mean this is how calculus works?
I don't think that's how this. That's how it works.
You're saying this has nothing to do with calculus whatsoever?
No, not really.
You know what, that would actually make a lot of sense. Alright, so for part A, we are presented with an equation stating that f prime of x is equal to 15x to the fourth minus 15x squared, equaling 15x squared times x squared minus 1. We are presented with both a clever number line and a nice graph, as well as some rain. Ultimately, because of this graph and number line, we find that when f is increasing, when x is less than or equal to -1, or when x is greater than or equal to 1. So for part C, we are tasked with writing the equation of each horizontal tangent line to the graph of f. So f prime of x equals 0 when x is equal to 0, plus or minus 1. We also find that f of 0 equals 2, and f of 1 equals 0, and that f of -1 equals 4. So the horizontal tangents are y equals 2, y equals 0, and y equals 4. So for part A, we are supposed to find each interval on which f is increasing. So we start with f prime of x, and that equals x times e to the 1 minus x power times -1, plus e to the 1 minus x, which simplifies into e to the 1 minus x times negative x plus 1. So the number line of f prime of x is positive to the left of 1 and negative to the right of 1. Ultimately, we find that f increases when x is less than or equal to 1. So now we have been tasked with finding the range of f. So f has an absolute max at x equals 1, and f of x is less than or equal to f of 1, and that equals 1. So the limit of x approaching negative infinity of x times e to the 1 minus x equals negative infinity. So we have yet another Celtic symbol of f equaling negative infinity, comma, 1, or more simply put, f of x is less than or equal to 1. Alright, we are now tasked with finding the x-coordinate of each point of the inflection of the graph of f. So the point of inflection we are able to find by using f double prime of x, and that equals e to the 1 minus x, and we plug in -1, plus 1 minus x times e to the 1 minus x power, and we plug in -1 once again. And that simplifies into e to the 1 minus x power times -1 minus 1 plus x, and that further simplifies into e to the -1 minus x times x minus 2. So the number line for f double prime of x would be negative to the left of 2 and positive to the right of 2, ultimately leading us to the conclusion that f has a point of inflection at x equals 2. And using the results from parts A, B, and C, we are able to sketch this graph here for part B.